Okay, so very easily then, if we confine ourselves to what we can actually do and don't try to use numbers that don't fit anything that I've got here, like that 8 centimeters per second, which is, it's easy to see how we could do that. We can say that dv dt is negative 10 times 12, right? Because we're given the value of x. That's all we need to get dv dt. Okay? And then knowing that that's in centimeters per second, that's negative 120 centimeters per second. Okay? And I just, are you watching me? I told you have to do that. Not centimeters per second. What is it? What did I do wrong? Just thinking about how to explain this and not paying attention to what I was doing. That's what I did wrong. But I do want to think about how to explain it. It's not in centimeters per second. It's in centimeters per second per second. Centimeters per second over seconds, because dv is in centimeters per second, dt would be in seconds, right? And that's where we get this. Okay? Now what is this? What's this tell us? What does centimeters per second tell us? It tells us how much change we have in velocity per unit of time, right? Mm-hmm. But if we deconstruct it in terms of what average rate means, okay? And I'm going to introduce a little terminology. You can ignore it if you wish, but it's like a delta V over delta T, isn't it? Except it's a dv over dt, which means it's a limiting value as delta t gets shorter and shorter, okay? And you don't need to worry about that to apply this, but I want to write it out, okay? So now, assuming the average rate stays at negative 120 centimeters per second for the next 0.02 seconds, okay, what do we conclude? Well, in this situation, the average rate is just what we said it is. It's going to be a delta y over delta t, right? Or delta v over delta t. And I can write it out like this. You know, obviously, if this equality is true, we multiply both sides by delta t, we get this. And now instead of writing the average rate, I'll write our dv dt, because that's what we're using for the rate of change, right? And that's the dv dt we calculated here. I did it again. Well, I'm going to slop it down here. And that gives us negative 2.4 centimeters per second. Okay? Now we've got additional information. We know that the velocity is 8 centimeters per second, right? And now what do we know?
That.
Velocity changed by negative 2.4 centimeters per second, right?
Yep.
Velocity was 8 centimeters per second. Changed by negative 2.4 centimeters per second. So now velocity is 8 centimeters per second plus negative 2.4 centimeters per second, or 5.6 centimeters per second.